Interpreter is also a language processor. Now you tell me, Java uses what? It uses a compiler or an interpreter?
Interpreter.
Ma'am, both, ma'am.
It uses both.
Both. Yes, yes, correct. It uses both. It's a kind of hybrid. So what's the difference between compiler and an interpreter? The basic difference?
Interpreter goes line by line.
Huh.
Ma'am, compiler converts source code to byte code. Interpreter converts byte code to machine.
No. Compiler, what does compiler do?
Compiler is whole. Interpreter is for line by line. In like in exception raising languages, interpreters are used. Like in any line, if an error is generated, interpreter will raise an exception.
Okay. So compiler takes a source code and it generates a target code. This target code can be a machine code, it can be an assembly code, or it can it has been written. Now what does the interpreter do? If it's an interpreter, you give source code and the input as well, right? So it goes line by line execution and it gives the output, isn't it? Now, what's the drawback of interpreter compared to the compiler? Can you compare them?
It's slow.
Correct. So the interpreter is slower than the compiler because it does many things together to give the output. Okay. Now Java is kind of hybrid. So once it is compiled, you get a bytecode which can be run on a different machine as well, right? So source program, it is getting converted into some kind of intermediate program, which you give that intermediate program with the input to the virtual machine, your VM, you will get the output. That is the hybrid of, it takes the advantage of both. Okay, so that is, these are all language processor or language processing systems. Now, if you put together everything, what's a language processing system which consists of, if you write a C program, right? If you write a C program, so what happens? The series of language processors which we require. So you have a higher level language. What is the first thing which we require? When you have macros, hash inputs, and everything you have. So, yes, correct. So it's the preprocessor. So you still get the, or you say higher level language source program, right? So this is the modified one, modified source program. So this next, once it is expanded, then comes the compiler, right? So which gives the, what is the output of the compiler?
Assembly.
So target assembly code is the output of the compiler, which I require something to get a machine code. What is the something?
Assembler.
Yes.
Intermediate
assembler.
representation.
No, that is inside your compiler. So I have already got the assembly code. Now, if I have to get a machine code which is relocatable, I need to have a assembler, which takes the input as assembly code and gives the machine code. Now, once I say it is relocatable, now I have libraries and everything which is separately compiled and kept. I have to link them together, and together I have to load it for further execution, right? So what I need next?
Linker and loader.
Correct. So it is linker or loader, which we require to get an executable or executable target machine code. Okay, this whole thing is called as a language processing system. Okay, clear? Now, this loader and linker, we also link the library files. Libraries are getting linked over here. Now, this is a language processing system. We are going to learn this particular language processor in detail. In detail, we are going to learn this particular compiler. We are not touching the assembler, linker, loader, neither the preprocessor. So system software subject had all these explanations of you had to learn preprocessor, macroprocessors, assemblers, loaders and linkers, how they work, all those things. Now that is not there. So we will be looking in deeper the compiler. So which takes the source program and it gives as the output the target assembly code based on the architecture, whatever you have. Okay, any questions? Okay. Now, once I say compiler, I have briefed you in the last class that the compiler is divided into several phases because it's a huge task of converting the source program into an assembly code. Okay, target assembly code. So, how many phases are there in a compiler? It is 6 or 7 phases which are there in a compiler, and each phase does a specific task. Okay, so the phase of the compiler is, if I have a source program which is fed to the first phase, which is called as lexical analysis. Okay, so what is the output of lexical analysis? This I will keep on repeating until this is fixed in your mind. How many phases are there and what?
Tokens.
Yes, tokens. Very good. So once I get the tokens, what is the next phase?
Syntax analysis.
Correct. So it is syntax analysis. So the output of this is a parse tree or a syntax tree. Both are valid. Okay. Now what is the next phase? I'll take an example and show you how each phase will convert it. A small sentence, arithmetic expression I'll take and I'll tell you how it is going to do it. So the next phase is called as semantic analysis, wherein we use syntax directed definitions and syntax directed translations to check the semantics of the generated syntax tree. Okay, so this again gives the syntax tree only, but with respect to the semantics, it would have been checked. Now, what is the difference now? Here it is checking the syntax, and here is checking the semantics. Semantics, for example, I write int a. Okay, tell me whether it's right or wrong. The sentence.
It's wrong. 1.2.
Huh? Is it an error or not? Caught by compiler?
Yeah.
If I write like this is caught where? In which phase?
In lexical analysis.
Lexical?
Syntax.
Syntax.
Yes, it is caught in syntax analysis because with respect to the syntax of the language, the rules of the language, it is wrong because I have to have one enclosing angular bracket. But in lexical analysis, this is separately identified, right? So int is identified, a is identified, this is identified, this is identified, and this is identified. So with respect to the alphabets of the language, it's right. But if I go with the syntax of the language, this is wrong. So if I write like this, int if I write 1 A B C, this is caught in which phase?
In the lexical analysis.
In this will be lexical.
Syntax.
That's right. This is with respect to keywords, regular expression, it will be passed by lexical analysis. But for the variables, what is the regular expression which we are going to use? It is a letter or a letter followed by a letter or a digit, right? With respect to that explanation, the lexical itself will throw you an error. Okay, so that is called caught in lexical analysis. This is caught in syntax analysis. Now, what about this? With respect to the syntax, is it right or wrong?
1 ABC is wrong. We cannot use numerics.
Syntax, is it right or wrong?
You're asking
Syntax
Ma'am,
is
int what
right.
it
ABC,
will
right?
raise
I
the
think it
syntax
will be
error.
caught in this syntax analysis.
Syntax analysis?
Yes,
Very,
ma'am. Because you
But
can't
one is
give a
not
float value,
permitted.
right? For array.
variables doesn't start with the numbers.
No, here I'm talking about this one. This is caught in which phase is the question?
Semantic.
Semantic? Why do you think so?
Because
Why do you think so?
array index should be integers 0, 1, 2.
Why it is not caught in syntax?
Because syntax, everything is right now.
Exactly. Correct. Sumit, right?
Yes, ma'am.
So syntax lexical will pass this because int a angular bracket is there, 1.2 is valid with respect to the alphabet is concerned. Where it is appearing, it doesn't matter in lexical analysis. So this is a valid number. Now this is also valid, semicolon is also valid. Now syntax, with respect to syntax, array declaration is right. You have an angular bracket open and you have an angular bracket closed. You have some number inside. With respect to syntax, it's right, but it
Ma'am,
fails
but
in
that
semantic
number
analysis.
should be integer, right?
That is defined in semantics. It is not defined here.
No, ma'am. Like
Type checking is not done in syntax analysis. Syntax is only the syntax of the language. With respect to the syntax of the language, it is right, isn't it?
okay, ma'am.
Now one more thing I will give you. D is equal to A plus B star C. Okay, or okay. Now this is integer. This is integer. This is integer. So this gets converted implicitly to float, right? Why it gets implicitly converted into float? What is the problem? Why it has to convert? What is the requirement? Why can't I keep it an integer only? So for the binary operator, you have a rule in the language. What is the rule?
Both the operands should be of same data type.
Yes, that's right. So the rule says that both the operands should be there on the same data type. So now, since I have, but syntactically, this is right. You have to agree with me for this, right? Syntax analysis will pass this on because I have for the binary operator, I have both the operands of one for all the operators. If you see, I have both the operands left and right. So this is syntactically it is perfectly fine. But when it comes to semantics, it checks the data types of the operands. Type checking is done. Now, in that case, if I have something like this, it has to first internally convert the value of C to some from into float, and then, but it doesn't change the data type of C. Remember that. Only for this particular expression, it converts the value to float, and then calculates this multiplication, and then adds it to TA, and then stores it back to T. Okay, so that is type checking. That is done in semantic analysis. It is not done in syntax analysis. That's why we have two phases. You might be wondering, both are giving syntax tree, but why we have different phases for each of them, right? So this is the reason I cannot combine because syntax analysis, if I combine the task of semantic analysis as well, it becomes complex. That's why it is split into two. So syntax analysis will pass this. Next is semantic analysis, wherein you do type checking and semantics of the language is also decided. Okay, so that's the difference between these two. I hope all of you are clear with this concept. Now, once the semantics is passed through, then what you do is you go with the intermediate form generation. Okay, so why we need this intermediate form generation is, instead of directly converting into assembly code a higher level language like this, it is better for me if I convert this into some intermediate form, okay, which is readable both by the user as a source program or a high level language, and which is also easy for me to convert from this intermediate form to assembly code. Okay, so it is an intermediate code generation, okay, or intermediate code generator. Here we use something called as tree address code. You will get to see each sentence can have maximum of 2 operators and 3 operands. That is the meaning of tree address code. It cannot have more than 3 address manipulations. That is the meaning. Okay, so it is also called as stack. Now this is intermediate form, which is easy for me from this to get converted into this. From here, I can get converted onto assembly code. Now there is an optional. This is the tag. The output is tag. There after this, I have an optional. This is optional phase, that is your machine independent optimization. Okay. So, or tries to optimize it. If it is possible to optimize it, it will try to optimize it. Then it gives the tag only. Okay, tag which is optimized. It is an option. It is not mandatory that you have to have this phase in. You can do optimization on the assembly code as well, okay, which is very. And then generate the assembly code and optimize it, okay, which is a little more easier. So now, once this is done, we are ready for code generation. So what is the output of this? It is the target machine code or the assembly code, okay. So now, after the code generation, we do code optimization. But this optimization technique is machine dependent. Why it is machine dependent? Because after the code generation, we would have used the instruction set and instruction format for a particular architecture, right? So that is depending on the architecture on which your compiler is running. So that's why it is machine dependent. So what is the output? Output is still your target machine code. Okay, is it clear? We'll take an example and we'll see how each phase will modify that particular source code. So how many phases? 1, 2, 3, 4, 5, 6, and 7. 7 with an optional phase. If it was not required, then it is 6 phases. With this, we have one more data structure called as symbol table. Okay, symbol table stores the tokens and its information. Okay, token name and an attribute value. I will show it to you. This table is accessible for all the phases of the compiler. Okay, this is accessible by everyone. Whenever they require a particular information about the variable or a particular token, then it can contact this table and get the information. Okay. Now we'll see one example how this is getting used. Mainly in this book or in this learning, what we do is we take arithmetic expressions only, because if I say other declaration statements and for loops and all, it involves arithmetic expression calculation. So more difficulty is in arithmetic calculations because we have operators, precedence, associativity, evaluation order depends on those. So we'll be learning mainly the arithmetic expressions, how it is being parsed and how the semantics is being checked, rather than like simple declaration statements, which is very easy to write, to understand. So the first we'll take some example, like I take b is equal to the same thing, a plus b star 60. Okay, so this is my source program or the character stream of my source program. Now, first phase is your lexical analysis phase. Now, lexical analysis phase will divide this into a smallest unit which it can form out of this to identify the tokens. Tokens are nothing but smallest unit of a programming language. So, how do I divide? How can I divide? I can divide on this, right? So, if you take a white space as the delimiter, or depends on how your lexical is written. Okay, when you see an operator, you can say, okay, the previous ones are a different token. So I can divide like this, right, till I get an enter or a white space or semicolon, right? So now, how do I form the tokens? Once I do this, there will be a symbol table, as I told you. It will have token name and an attribute value. This is symbol table. Okay, this is the first lexical analysis phase. I just say it as LA. Okay. Now, a series of tokens will be formed. Now, D. Okay, D is nothing but how do you say D will match with the pattern for a variable, right? It's not a keyword, it's not an operator, it's not a special symbol or a white space, right? So it is matching with a pattern for a variable, which is nothing but what is the pattern for a variable? It is letter followed by letter or digit. So it matches with that pattern. So whenever a series or a group of characters they match with a pattern, they will be forming a token. Now, the series or a group of characters which can match with a pattern is called as lexeme. And don't worry, you just remember these words because in detail lexical analysis we'll be learning again. Okay, so lexeme, we say lexeme will match with a pattern to form a token. Okay, what is lexeme? Lexeme is a group of characters which can be mapped with a pattern. So if I have something like position or some variable name, okay, this is a valid variable name, right? Now if I take position, it matches with the pattern for a variable. Now till where it keeps reading until I something like this. If I have int space position or a comma, I have until I get a different symbol or a different character which cannot be grouped together for a variable pattern. Okay, so till then it reads. The reading technique also we will be seeing in lexical analysis. As of now, you just remember that lexemes will be there which will be mapped with a pattern to form a token. Okay, now D is an identifier, A is an identifier, B is an identifier, others are operators, and 60 is a number, right? So now how it will form the token is, it is like this. So ID, comma 1. So for each type of token, each type of lexeme which can match with a pattern will have one token name. I cannot have multiple token names for each of the identifier because in a program I can declare so many variable names, right? I cannot keep a distinct token name for each of the variable. Suppose if I have here only you have DAB, 3 variable names are there. So I cannot have one token name for D, one token name for A, one token name for B. No. For a particular language, for an identifier, I will have one token name. Somehow I have to differentiate between the different variables using the same token name. So what is the differentiating character is this. Okay. So I say 1 in the symbol table. Okay. So it is D. The name of the variable is D. And here I will store the information regarding D. What are the informations? Its type. It could be its type, its scope, its value, right? So those informations can be stored over here. So whenever together it is a token. Remember, this is together the token. So whenever I see ID comma 1, if I go to 1 in the symbol table, okay, address 1 in the symbol table, I get the information about what is the variable name, what is its scope, what is the type, and all those things. All those informations I get about D. Now, what is the next one? Next one is equal to. It's an operator which is fixed for a particular language. So I take it as it is. Now, what is next? I have A, which is again matching with the pattern for an identifier of variable name. So I have to take again, it is the token name is same, ID. Okay. Now it is the attribute value is 2, which is referring to the symbol name table entry 2. What should I enter here?
A.
A. Then here will be the information regarding A. For a language, the token name has to be same, right? So if suppose I have this statement, B is equal to A plus B plus C. Okay. Now plus is appearing 2 times. Will I have 2 different tokens for these 2 pluses?
No, ma'am.
No. So in the same way, how many ever identifiers I have, token will be same, but its type might be different, its value might be different, okay, and its scope might be different. The lifetime of this variable might be different. All this information I will store it in the table, but I cannot have multiple tokens for the similar types. Got my point?
Yes, ma'am.
Huh. So that's why what we do is in the symbol table, we store the variable name and the information regarding that, and we give the link of this table name as an attribute value in the token. So now attribute value is an optional one. Okay, remember that. So attribute value is an optional. Each token might not have an attribute value, in which case it will not have an attribute value like this. Operators, it will not have an attribute value because it's fixed, right? If I have a keyword, okay, it will not have an attribute value because it is fixed for a language, right? The data types, the keywords are fixed. All those things. For the numbers also, it will not have an attribute value because it's a value. It is fixed. So only for the variables, we will have an attribute value. That's why it is kept as optional. Okay. Now, the next thing is plus. So I take it as it is. Then, or you can have plus. It depends on, because for simplicity, I'm taking the operator as it is. It's a token. Okay. The next is b, id, comma 3. So what it does, it makes an entry here, b, and the information regarding b. Okay. The next one is star. Then the next one is 60. So both of them, they doesn't have an attribute value because they are fixed for a language. Now this is the series of tokens which it generates after the lexical analysis phase. Any questions?
Ma'am, why the entry is only made in the symbol table for only the identifiers?
Because they have different information, right? For the fixed ones like operators, keywords, all those things are fixed for a language. What is varying? Varying is the variables. It can have a different data type because I cannot fix in a language, say all the variable names have to be integer. That's not possible. So it depends where I define them, how I define them, how I give the values. All those things are defined, right? So that's why we have the symbol tables only for the variables, most probably for the variables.
Yes, ma'am.
Okay. Any other questions? Now we move on to syntax analysis phase. So syntax analysis phase is a crucial one. Once you form the tokens, you have to form the syntax tree. But why we form the syntax tree? What's the difference between the normal tree and the syntax tree you would have studied in DA?
The operator is the root.
Operators?
Operator is the root.
Huh. So intermediate nodes are operators, and the operands are always the children
Leaves.
for that particular leaves. Yes. Now, how do you form the syntax tree for this? Anybody can guide me?
Equal to will be the main root node, and D will come on
So
the
the
left
equal
side.
to, you have id comma 1, then this side plus is there and star
Yes.
is there.
So I think plus will come. Yeah, plus will come, and then on the left hand side it will be ID2, then star on the right hand side, and on the left hand side of star will be ID3, and right hand side will be 60.
How you decided this?
Based on the order of calculation, the precedence of star is more than plus,
Higher.
so that calculation will be done first.
So you traverse this node in some method to get the value. So if I have to calculate the value at is equal to, I need the value from left and right both. Since I have the left value, but I don't have a right value, I have a node again here. So I have to calculate this. To calculate the value here, I need both the operands. So left operand is already there, but at the right side, again, I have a operator. So I have to calculate the value here first. I have to check both left and right. I have both the operands to calculate the star. So I calculate this, get the value here. Now I get both the values for this plus. So I calculate plus. Then I get both the values for this is equal to, I get the value getting stored back onto the ID1. So this is your syntax tree. Okay. Once I generate this, it gives me the evaluation order as well, right? So once I do this, the next task is to check the type. Okay. Suppose now D, A, B are floats. All are float variables. 60 is an integer. Now this is a semantic task. Now it has to do implicit type conversion, right? So what it does is, I'll just erase this. for the next phase. For this part, because I cannot change the data type of this, it's an integer. Now for this operation, since this ID3 is float and 60 is an integer, the requirement of the language says that for star I need to have, since it's a binary operator, I need to have both of the same data type. I cannot downgrade with respect to the language. I cannot downgrade this float to int, so I have to upgrade this into float. So once this is the input to the semantic analysis phase, again the output is syntax tree only, but with the semantics or the type checking have been done. So this will give me something like this. Somehow I have to tell the compiler that I have to code the compiler that it has to upgrade to float before performing star operation. Okay, so what it does is it includes a node wherein that conversion happens. Okay, so 60. Right, so this conversion happens at this particular node, the value conversion happens, so this becomes 60.0 over here. So star, with respect to the rules of the language, now it is satisfied that for star I have both float values, it gets the value over here and plus and then is equal to and then this one. So that is how the implicit conversion happens. Okay, implicit conversion, it includes one extra node over here after the semantic analysis, and also the output is still a syntax tree. Clear? Type checking happens in the semantic analysis phase. Now once this is done,
ma'am, like
next is
how does it know that all others are float? Like, does it look into the symbol table before and then
yes.
does this?
Yes. Okay, so it checks. That is what all about in semantics, right? Type checking. So whenever I see ID 1, I check the type of this particular variable. I have to have a search. Okay, so it checks the types and then decides whether the whether the types are matching or not matching and all this.
So ma'am, if suppose that D is of integer type and rest all are float, like, and even this 60 is of integer type, so then it will, what will it do? Will it put a note
An error, right?
float to int or like directly error?
No, even then, see, if this is float, and this is int. It will get converted into float, right? So this whole thing gets performed in float, and then it is getting stored back to integer, which is not possible because the memory won't be enough. So it has to throw an error because the memory requirement of integer is different than float.
What I'm saying is, like, will it throw an error before doing the calculation on the right hand side, or will it throw an error after calculating?
No. Calculation can happen only when I get the target code, no?
Yes,
Now
that's what I'm saying. Like before ID1, will it make a note that float to int, or like while making the note itself, will it throw an error?
see, compilation is what? You're not executing it. You don't get the value.
Yes.
You don't get the value. You are just compiling your program, right? You are inside the compiler now. After I get the machine code, only then I can get the value of ABC. So the calculation never happens. It has to check whether if I do the calculation, then what is the type? It just takes the types. It doesn't check the value. It cannot have the value, right?
Yes, ma'am, the type only.
So, execution
like,
not it happened.
Okay. So, like, as we discussed, like that error will come in the semantic part, right? So, how will it get that error?
How that gets that error is based on this. So star is a binary operator. The rule says that both should have the same data type, right?
Yes, ma'am.
So in that case, is equal to will not have the same data type. And what is equal to means? That I would have coded in my rules, no? So is equal to means you are storing this side value to this side value. And this side value have to be is equal to this side value, or it has to be more. It cannot be less. That is also one of the rules. For me to go with the rules, I need not have the values with me. Values will come only when the syntax is proper.
So, like, that's what I was asking. So, like, it won't move further, right? When it hits the error, it directly reports the error.
It doesn't go further. It directly reports here.
Yes.
That's why you don't, until you solve all the errors, you will not get a.out file. You remember this?
Yes, ma'am.
Why you will not get? Because it has to pass through all the phases. Then only it is able to generate the assembly code with the object code. Otherwise, it will not generate. Why it will generate? It will not generate. So any phase which catches the error, it will directly report it. So there are different ways in the compilers, which is being implemented in the compilers. When you would have also experienced this. Whenever if you have multiple mistakes in your program, suppose I have multiple mistakes like int a, I did not give the semicolon, int a comma b, I did not give the semicolon again, or something like that. You have okay, something like this. Okay, so now some of the compilers which are being implemented, the simplest ones which are being implemented, because these things are caught in syntax analysis, right? So the first statement is also having an error and the second statement is also having an error. So whenever it sees the first error, okay, it immediately stops the compiler and says that, okay, in this line number you have an error, you correct it and then go further. So once you correct this error, you might get other errors. Have you experienced this? More errors once you correct the simpler ones. You would have already experienced this, right? So that is a very simplest compiler. More complex one is, what they do is whenever they see an error, they log it somewhere. The next statement, log it somewhere. So together, they'll show it back to the user. Say all these line numbers have the errors. And once you keep clearing them off, you will not get further errors. Okay, this is little more complex one because you have to log it and then log the line number, log the errors and all those things. Okay, that is about how the compiler is being implemented. Now, we are talking about a single mistake. Whatever, wherever it is caught, it immediately says that that is an error in your program. It doesn't go further in the phases. Okay, it stops there only.